It's always the case that the breaks are never long enough, but I hope you had a chance to at least grab a cup of coffee, say hi to a friend or two, maybe make a new one. And now to re-engage. I'm really thrilled to have this next pair of presenters, both from the Department of Forest Resources, and to talk about some really exciting applications of some of the technologies you've heard a bit about already. Our first speaker will be Dr. Joe Knight. He is an associate professor in the Department of Forest Resources, Remote Sensing Geospatial Analysis Laboratory. His research focuses on using geospatial science methods, such as remote sensing and GIS, to understand and quantify the impacts of land use on our environment and natural resources. Dan Heins is his close associate, and he's the operations coordinator in the UAS lab of the Remote Sensing and Geospatial Analysis Lab. He is an FAA certified remote pilot in command and holds a certification from USGIF in GIS and analysis. He is broadly interested in data acquisition, analysis, and production to support sense making across the spectrum, we should all be so lucky, of natural and human activity. So Joe and Dan, looking forward to hearing your presentation on UAS applications for invasive species, opportunities, and challenges.
All right. Hi, everybody. I don't know if I can live up to that introduction, I guess, but we'll see. Oh, yeah, microphone. Sorry. When I teach in lectures, I like to roam around, and I'm going to have to confine myself to this thing because Dan has the mic, so apologies for that. I'm just going to give you a quick overview of the lab and what we do, and then turn things over to our expert, Dan. Dan's the UAS coordinator for our department and largely the college as well. So if you have UAS operations questions or requests or information about missions and things like that, he's the one to talk to, UAS@umn.edu. Okay, so we're going to talk to you about applications in invasive species for drones. All right, so just a quick bit about the lab. Well, the remote sensing lab's been in existence since the 70s. Back then, photogrammetry was the main activity, but we've developed through the years to use satellite and aircraft data, and now, since about 2015, UAS. So initially started work under the COA that the university had, and we've now moved into Part 107. We have multiple Part 107 licensed pilots for various types of missions, and we've flown quite a number of those over this time. So we do sort of a tripartite mission in remote sensing, including UAS, so we teach quite a bit. Dan has done a lot of work with developing UAS and remote sensing content in courses that are taught here by a number of different instructors, and as you can see, GIS, remote sensing, and GPS. We have a drones course that you may or may not be aware of, so there's at least one of our former students in the room here. Hi, Cade. We didn't turn him off of the field, so I guess it's a good course. It's taught every spring, 3 credits, meets once a week, and then we do a lot of outside work, flying, things like that. We do workshops all over the state, online, in person, et cetera. Our mission focuses on the intersection of natural resources, natural resource management, and geospatial science, so a wide range of different remote sensing topics, and of course drones are a big part of that. We have a significant number of graduate students and research staff that work in the lab, and we focus on the applications you can see there, among others, among many others, now more recently getting into wildlife habitat type studies. We've done quite a bit of outreach, and we continue to do that. So if you have public events that are related to remote sensing or UAS, we're happy to come and present, or do like a drone demo or something like that. So we've done a lot of it, and we continue to do that. So there's your overview, and I will turn this, maybe I'll let him advance that, turn this over to Dan to give you the expert info about drones.
All right. Well, what a couple of great presentations we've had so far. So I think you're going to hear me mention a couple things that have already been said, because clearly we have some knowledgeable people who hit on a lot of the key points. And one of those key points that Atina mentioned is perhaps our greatest strength with unmanned systems is that the temporal resolution is something you largely determine yourself. You're not waiting for the next satellite pass. You're often less weather limited, and so forth. But to do these things at the time and place of your choosing, within the regular environmental constraints that you would expect, is very powerful. We've seen some great examples so far of some very high spatial resolution products. And so this is obviously a great strength as well, particularly when we're looking for invasive species which may physically be very, very small. Just to give you an idea of that, so sort of our commercial space-based systems, kind of the best we're doing is about 30 centimeter ground sample distance. Well, just kind of your standard higher end camera, RGB camera, operating at 122 meters or 400 feet, our legal limit, yields order of magnitude better ground sample distance. And of course, it doesn't take a rocket scientist to do this. Anybody that's dedicated and motivated can master these things. That said, you've got to know your stuff. There is a perception sometimes that, I'm going to go buy a drone and, magic is going to fall out the other end. And that's just not the case. I mean, there is some work and some expertise involved in doing many of these types of analyses, no matter what our area of interest is. And certainly a number of products can be derived, and that is not an exhaustive list. The first speaker and second speaker, of course, talked about cost. Many of these systems, aircraft, sensors, the combinations of the two, can be had for a fairly modest cost. So, Joe's mentioned some of the things we do. A lot of it happens in the forests. So we do a lot of forest inventory type work. So on the top left, we're looking at things like DNR plots to validate and verify the measurements that they're doing in their plots. We do some event response stuff, so weather events, blowdowns, et cetera, to try to plan salvage logging and other types of operations like that. Joe mentioned a little bit about wildlife down in the far corner there. We were looking at the number of leaf trees and snags that were left in a sail area that were specifically intended to provide habitat for fishers. And the fishers were specifically wanted to combat porcupines that were girdling trees in the area. So, it's a cycle. We do a lot of urban forestry as well. So everything from, looking at greenness studies and the health of cemetery in this example, to standalone trees looking at the effects of, overall and woody biomass on treatments for urban trees. I'll talk a little bit more about this later, but Atina, hit on something, automation, right? We want to do these things very quickly. We want to automate those processes. Our laboratory does a lot of work with what's called object-based image analysis, and so we're pretty heavily invested in developing object-based techniques to do feature extraction. And of course, we work a lot with spectral information as well. On the research side, we do a lot in research plots. This is a white spruce research plot where a very accurate canopy height model was needed to determine accurate heights for each of these trees in this plot. So forests, we're in the forests a lot. The other thing we do a lot of is wetlands. Last couple of years, we've been pretty heavily involved with the Great Lakes Restoration Initiative, mapping, monitoring coastal wetlands in the Lake Superior area. Up on the top left, real interesting, this year we started to look at a lot of the fens, or some of the fens rather, on the North Shore. That's the Icelandite fen. And I had not previously seen this. This is just a little tidbit. You can see these are point clouds. You can see here the water was clear and not too choppy that day, and I was surprised to see that it actually managed to match points beneath the water, optically match them, not correctly on the z-axis. So we do a lot of wetlands, and a lot of that is related to restoration work. Monitoring mitigation and restoration efforts to make sure that's all going well. But part of that wetland work has really started to spill over into the invasive species space, looking at things like Phragmites. And I'll talk about that just briefly later. Because we've had a couple good discussions about case studies and particular applications, I thought it might be handy to maybe step back a little bit and just talk about the how. How are we going to do what we're doing? Are UAS the right tool for this, right? I mean, the speakers have certainly illuminated some of the limitations, and I think I risk repeating some of those as well. So there are some questions involved in whether this is the right thing to do in the right time, and of course I believe the answer is it certainly is, with some caveats. So we're looking a little bit about Phragmites. Joe mentioned that we have many graduate students and researchers working in the lab. One of them's here, Connor Anderson. Connor, raise your hand. Oh, there he is. He's going to be taking a real close look at Phragmites and Phragmites in the Duluth area over the next coming year or so. So we have had the opportunity. Now this is Grassy Point in downtownish Duluth. I don't know if anybody has heard about Grassy Point in the news. There's a lot of money going there right now, and some real restoration efforts are really ramping up. So we've been out there a couple different years, and this is just a quick slide. We work a lot with elevation information, so heights information. We work in the 3D world quite a bit as opposed to the 2D world, and a lot of that is related to generating volumetric related measurements to measure things. But I'm not going to talk a whole lot about Phragmites or anything right now. But again, object-based. We've developed some techniques that enable us to pick out Phragmites to a certain extent. Of course, we're still developing these. So I mean, to borrow a term from defense intelligence, is the tactics, techniques, and procedures, right? We're trying to develop those to address certain species. What we need to do, how we need to operate in order to find these things. We talked a little bit about aircraft. I'm going to go really quick over this, right? So there's all different kinds, right? And there is no best for everything. A couple types might be called a Swiss Army knife, but certainly for your application, there is a best, there's a not so good, and there's a one that might work. So if you have any questions about aircraft types, I'm sure there's lots of experts here in the crowd that can help, but I'd certainly answer anything as well. So when I look at this process, what is our approach? So maybe we can break it down into some phases. So identification. So do we know how to identify it? And this could be in a lab environment, in the field environment, with in situ data. What is that sensitive signature of that species that's going to allow us to extract it from the overall surrounding sea of information? So we can do that via a number of ways. But then the next step is detection, right? And identification and detection sound a lot alike. But Detection would be being able to do that in an operational setting, right? So when you're out in the field and you don't know anything about the presence of a species, are you able to then extract it as easily as you could in a controlled environment? Localization, so precisely measuring where it is on the Earth. And this is important, and Tina had a slide on ground control points and so forth. But over the last few years, we're kind of evolving on the natural resource side. A while back, one of the common ways of thinking was that while this may be necessary in construction, and real survey, boundary survey, and things that had legal implications. For natural resource work, accuracy wasn't so important. If we're within a few meters, maybe that single frequency GNSS aboard the vehicle itself is going to give us what we need. Well, increasingly we find out that doesn't really work. Particularly when you're on the research side of things, and you need your results to be reproducible, and you need to track things across longer time horizons and nail all this data together to really do management. Monitoring, and that's just kind of, we're looking at this looking at these phenomena over a period of time, and so we can measure change. So change detection is important. And then treatment. We haven't really talked too much about treatment yet, but is there a place for drones in treatment? So can we take measures using drones to actually address some of these things? With identification, I'm sorry for the wordy slides. I don't have so many great pretty pictures. With identification, there are so many factors that really play into not only the aircraft you select, but the sensors you use, right? Is your invasive species big or is it really small? Tina talked about texture, right? But shape as well. I mean, these are things that are unique to each species, and we have to be able to marry, how we, the sensing modality we use, the sensor, and how we collect, what products we need to detect things in this way. So another thing is, are we looking for the pest or pathogen itself, or are we looking for the effect of the pest or pathogen? So are we looking, well, I think that's fairly straightforward. Are we looking for the cause of the effect? Oh, did I skip one? Okay, so detection. Like I said, how can we operationalize these findings? Well, one way is that we can spread the word. And again, Tina mentioned the importance of interdisciplinary work. So we have to share what we learn and work across disciplines. And I know sometimes this can be difficult in academia. People like to protect their rice bowl often, but it just works better for everyone if we can share our knowledge. Again, develop those tactics that are suited to the species to detect it, and automation. So we need to generate some of these methods for automated detection. One thing that people come up against, and a lot of times when they are buying system solutions from vendors, is that they then go back, and this is pretty specific to a research setting, they then go back and try to use some of this data, and it turns out that the data is locked in a proprietary format. It's been dumbed down, downsampled, or the bit depth has been decreased or something, and it makes it really difficult to use for a lot of research purposes. So I'm a big fan of open source as well, but certainly you need access to the full resolution raw data, and sometimes that's not the case. So just be wary in your purchasing and whatnot, and make sure that you're going to be able to get the data you're going to need to generate the results you're looking for. And of course, in terms of sharing, GIS-ready products are great to share with your colleagues. Talked a little bit about the importance of localization and accuracy. So this is a point cloud, that same point cloud, well, 2 point clouds, of that Phragmites patch in Duluth. So what you see here is this Phragmites patch laid one on top of each other, one a 2018 collection, one a 2019 collection, both processed exactly the same way using the onboard GNSS, right? So what we see here is about a 22-foot separation in these point clouds, just using the single frequency onboard GNSS, which we all know has about a 3 to 5 nominal, usually it's under that, but nominal 3 to 5 meter error in the XY with sometimes a 5 to 10 meter error on the Z. So actually it's not surprising. And if one date you're biased on the high side, another date you're biased on the low side, that's just compounding error. So this is okay for an objective, a client or whatever that says, I just want to know what this looks like now. Reconnaissance, let's call that reconnaissance. Something where you're going to come back and you're never going to be there again. That doesn't really require that great geometric accuracy. So you're just talking about your relative scene, not your global scene. A one-time deal, okay, that might work for you sometimes. But if you're concerned about acquiring data sets of the same geographic area over time, it's absolutely necessary to nail it together using high precision GNSS and precision positioning. Another thing, we do a lot of fusion. I don't know if fusion's the right word, but for example, with heavy vegetation, right, and if we're using photogrammetric point clouds, heavy vegetation really presents a problem in finding the ground or whatnot. So we're often using LiDAR ground, mixed with our photogrammetric point clouds to be able to measure things more accurately. That works a lot better as well if you're just using ground control or whatever type of solutions you don't want. It can be PPK, it can be RTK, whatever. But precision becomes more and more important. One of the things that we've discovered along the way is, and I'm not going to say there aren't ways of correcting this in post, right? So post-processing, you work hard enough, you can usually get things kind of where they need to be. But the amount of time and effort that's spent doing that is immense, typically, because a lot of these operations, shifting between vertical datums, et cetera, is really a pain in the butt. So it's better to do it right on the front end and get that precision where you need it. If you're directing field personnel to address some of these invasive species or whatnot, in our case, it's become evident. An example, the DNR has many forest plots spread out across the state. And they are increasingly moving to using high precision GNSS. Yes, do you have a question? Oh, okay. Sorry. Hi. So they're increasingly using high precision GNSS to mark their plot centers. Well, their plots are only 1/10 of an acre. So when, we need to be able to really marry that plot center up with our data, because if we're talking about only 1/10 of an acre and suddenly, we're 5 meters one way or the other, we're not going to be counting a large percentage of the trees that are in their plot or misidentifying them in terms of species. So just being accurate geometrically, we found is increasingly important for us. So monitoring. As we look at these things over time and some of these, considerations, we talked about buckthorn, right? I mean, buckthorn's really popular because everybody knows about the, unique phenology of buckthorn, right? It's going to be green when everything else is, kind of senesced and the trees and the leaves are gone. And so that does present an opportunity. Turns out it's not really as easy as that, particularly when you're talking about buckthorn in an environment where there might be some complex overstory or even the understory, in and amongst the buckthorn is very complex, makes pulling it out a little harder. But there's a lot of, and these are mostly mission planning considerations that are involved in monitoring. So by the time you get to monitoring, you essentially know what you should be doing. And some of the metrics associated with monitoring, of course, is it getting bigger? Is it getting smaller? Are the good things becoming more prevalent? And are the bad things going away? So some of our takeaways. Did I? Treatment. Oh, okay. So treatment, what role is there? So applications, we see this in, not only starting to become more popular for crop spraying and whatnot. Not super popular right now. I mean, the Chinese have covered an area the size of France at this point with spraying drones for agriculture. While we've got, some of these DJI Agres products are out there. A lot of people are running these big Yamaha copters, RMAX and VMAX. So the application of pesticides and herbicides. Is there, I don't know if this is going to fire off here, hopefully. No, it's not going to, is it? Bueller? Just one video, and my video is more funny than anything. Well, I'm not going to sit up here and wait for that. This is a video fire. So right, am I joking? No. So a lot of the recommended treatment for some of our terrestrial invasive species is burning, right? And so you Google it yourself. It's hilarious. The DJI M600 with a flamethrower on it, burning stuff away. Where is it?
Introducing the TF-19 Wasp Drone Flamethrower. The Wasp is built to withstand all sorts of conditions, both cold and hot. With 25 feet of range and 1 gallon of fuel capacity, the TF-19 Wasp can deliver over a minute and a half.
That's a little bit funny, but
hey,
is there an application for it? If the treatment is burning, why not have a little fun while you're burning? Go back to full screen here. So our takeaways, and certainly this was alluded to before, this is not a broad solution for broad geographic areas. At this time, this is really for limited geographic areas until such things as beyond line of sight flight can be solved, which really, realistically, is not that far down the line here. They're working out unmanned traffic management and so forth. And certainly that's going to help us because, I mean, like you had in your slide, geometry is the problem when you're working in the forest, right? Because that big tall tree right in front of you limits your line of sight instantaneously in some cases. So, that lift truck, that's a good idea, but that's a logistical complication that you often don't want to when the whole point of the exercise is to take a drone and throw it out there and get what you need. So that's going to work itself out. So it can be effective at limited geographic extents right now. Great to see what you had on early detection with oak wilt. But one of the things that I've thought about is, because of our limited geographic scope here, early detection across a broad scale is not really likely right now. And there are certainly many species that are not addressable at this time with unmanned systems. So is there an invasive species spectral library somewhere? Is there? I don't know, but databases. So if we can, employ some of these cost-effective hyperspectral sensors and build up good spectral libraries, well, that goes a long way to making our job a lot easier. And this restates some of it. The automation is really important for us. Yeah, I think we'll wrap there. Yeah.
Thank you.
Questions?
I think we have time for one question for
One question.
Joe or Dan.